Yeah, okay. So, the switch. What is the switch? Now, before I read to you, and if you want to know what I'm reading, please refer to the previous video. I mentioned that the switch does have a personal application, and I'll share, but I think I should do that after the technical discussion, and so I'll put that thought on hold. Now, switch. What comes to mind when you hear the word switch? Sounds like something teachers always say, and no one ever raises their hand. What comes to mind when you hear this? And the whole class is like, okay, tell us what you know. So, but really, what comes to mind? Right now, I'm looking at a socket, and the socket has a switch, right? On and off. Same thing for the light. There's a light switch. And even the fan, it's a fan switch. But is that the kind of switch we are talking about here? We'll find out soon. Now, to understand why we'll need a switch, think about it. You have about 50 computers. You can't work with a ring topology. Ring topology is maybe I connect a cable from PCA to PCB, PCB to PCC, PCC to PCD, all in that order, in a circular manner. No, right? If I want to send from A to F, it has to go through B, C, D, and E. What if the link between B and C breaks? That means I can't send my packet. I can't send that important information. That message to my boss to tell him I need leave to go home and rest. That message he will not receive it because of the topology. But if you want to make use of a mesh topology, now what the mesh topology is like one to many mapping. It's not one to one, right? So A can communicate with B, C, D, E. E can communicate with A, B, C, D. C can communicate with A, B, D, E. In that order, they can all communicate with each other. In order to make that possible, you don't need a lot of cables and a lot of network ports. No. And a lot of RJ45 cables. No. What you need is a switch. You just connect it to the switch, and the switch handles the rest. So now you're like, okay, who is this guy called Switch? What can he do for me? Please. A switch has a few ports or connectors which connect different nodes and devices to it by cables. So you can have an 8-port switch, 16-port switch, 24-port switch, even a 48-port switch. Right, those are all where the network cables will go. You see that weird shape the RJ45 has. There are a lot of those ports on the switch. So connect your computer, you put it in the switch, you put the other end in the switch. One end goes in your printer, your network printer, the other end is another port on the switch. Now let's keep going. Find out what exactly this switch does. What makes it so cool? Good. A switch also has a MAC address. Yes, true. Since it has a network interface card, it should have a MAC address. And in addition, a switch contains memory where it stores the MAC address of all the devices and computers connected to it, which is very crucial. The switch has to know, okay, this frame just came in. Where is it from? Where is it going? Right? So the switch has to know every device on the network. Okay, this is the printer's MAC address. This is desktop user A's MAC address. Desktop user B's MAC address. This is the HR's MAC address. The CEO's MAC address. The network engineer's MAC address. It needs to know all of this. And we'll find out why very soon. And so when a frame arrives at a port, the switch stores the source MAC address, port of arrival, and timestamp in the content addressable memory, which is the CAM table, commonly known as the MAC table, right? What does this mean? I sit behind my laptop, I type a mail, I press send. It's going from my PC to my boss's PC, right? So yes, it will go through the switch. But once it enters the switch, once the switch picks it, what's the switch looking at, right? The switch is looking at my MAC address, which is what we call the source MAC address. And so it's like, oh, okay, Alvin, yeah, desktop user B. Okay, I know the person who sent it. Port of arrival, which particular port I used, right? And then the timestamp, what time did this come? And what's also important is the destination address. Where is it going? Who is going to receive this? And so the more frames the switch forwards, the more MAC address it stores in the MAC table. And the more MAC addresses it stores in the MAC table, the faster the message is forwarded to the destination. I'm smiling because I like the way I'm talking and explaining it. It sounds sweet. But what this means is, think of it like a cache, right? CACHE. Once you have a cache of maybe www.youtube.com, maybe first time you typed it in, it took about 3 seconds to take you there. But once it's in the cache, in less than a second, you are there. Why? Another illustration. It's like you going somewhere for the first time, right? Or you going with someone to some place for the first time. Let's say you're going with me somewhere and it's my first time going there. You have never been there. So I get lost a bit, I ask for directions, I mislead you, we walk a lot, eventually we arrive, right? Imagine you could do it all over again. Wouldn't you rather go with someone who had already gone there before? So it's just, he knows where he's going. He's going left, he's going right, he's going straight, he's going there, right? So that's how it is when you have your MAC address. So all the all the MAC addresses connected to the computer are kept on that table. So if the switch gets that packet from me, sending it to my boss, it checks the MAC address, it immediately links it to, oh, okay, that's the boss, that's desktop user C. Because if it wasn't in the MAC table, do you know what that means? That means that the switch now has to go and disturb every device on the network. Charlie, is this for you? Okay. Oh, is this for you? Okay. You, is your MAC address this? Is this yours? No. Okay. You. Okay, yeah, it's for you. That's a long process. It will take a while for boss to receive it. But if you already knows where the recipient is on the network, it's faster. And that is as a result of the MAC table. Hope I haven't overtalked this thing. And so, in addition, the earlier switches, it's good to know our history, right? So that when someone tells you, oh, this maybe he's trying to sell you a switch, you have reached that point in life where you're a big man, yeah, you're buying switches, and you go like, yo, I want to buy a switch. It's good to know the history, so someone doesn't sell you an archaic product only for you to get home and realize, this is useless, right? So in those days, switches used to work in half duplex mode, right? And in this case, only after one node in a network would complete data transmission would the next node be able to send data, right? Think of it like having one door. If I'm going and I see you, I have to stand for you to count before I go. Normally, as normal human beings, we are supposed to do that. Most people don't care. But realistically speaking, it's not possible. You can't put squeeze through a door. So you wait, the other person goes before. But imagine a lot of people are coming. And you are just standing there, getting impatient, waiting, right? That's half duplex mode. But then the newer switches are full duplex devices, right? And they can be integrated with full duplex nodes to provide full duplex communication in a collision domain. What this simply means is now you have two doors. right? In and out. Isn't it easier that way? You don't have to wait. If someone is using this door, you just go to the other door and get out. Let the person take his time coming in. It's simpler that way. And that's how the newer switches are designed, right? So if I'm sending something to my boss, that doesn't mean everyone on the network has to wait for me to send it. No. I can be sending, and my coworker is also sending an email to the HR, and the HR at the same time is also sending something to desktop user D. Right? Excellent. Oh, I wish I could show you a picture. Please Google it, okay? What should you even type? Just type switch in the network and go to images. I'm sure it will sharpen the understanding, you see. Yeah. What I'm trying to do is the things that are here. Yeah, I want to take this opportunity to use the illustration. I love this illustration. Let me get to it. The things that are here, I'm looking at it like they are in 240 pixels. They are not clear by themselves. But with additional research and study, I can increase the resolution from 240 pixels to 720, or dare I say 1080, maybe even 2K. Regardless, I make it sharper and I make the understanding clearer. But you can go the extra mile by checking out some images. For now, I don't have a laptop, so I can't really do that with the phone that I'm using. So you just be seeing me talk. Let me not, get sidetracked. The star of this show is the switch. Now, there's something called PoE, Power over Ethernet technology, right? And so it enables standard Ethernet cables to transfer electrical power along with data to remote devices. So using this technology, switches and other network devices can accept the power from the Cat5 or Cat6 cable by using the RJ45 jacks, right? It's like our phones. I can use the same cable. I can connect that cable to my laptop, and even before I start sending devices, it is charging. In the same way, you can have that power over Ethernet. So you connect the switch, you connect an RJ45 cable into that port, into the network port at the back of the switch, and connect it to a wall jack, right? Connect it to one of the ports in the wall jack, just like a normal device, but it will charge, it will draw power from that connection to keep itself running, right? And so another thing to notice, the switches have operating systems and they vary. Cisco has, Dell EMC has, then other brands have, Nutanix has, Huawei has, do Oracle people have servers? I think so. They have, right? But they are all different operating systems. And this is very important. This is very important because the switch interfaces are configured through specific command line tools. And if the operating system for that switch is different, you can't expect the command line tool you used for Cisco, that same set of tools, you can't expect it to work on Cisco and also go and work on Dell EMC. No, there will be some changes, right? So we need to make room for those changes. It's like a language with different dialects. And so there's something called a multi-layer switch. We need to understand that this switch I've just discussed operates at the layer 2 of the OSI model. And if you have watched my video, nobody watched it. Why are you doing that to me? But if you did, you'll see that the layer 2 is the data link layer, right? And so once we mention a layer 3 switch, we are talking about what? An extra step forward, which is the network layer. And what makes this interesting, right? The selling point is this switch doubles as a router. Now that's amazing, because, and I'd love to discuss the router in the next video, but just to give you a gist, if you're connecting two networks, you need a router. Let's say the switch has connected all the devices, but then they're all using the same subnet, right? 192.168.1. Then you have 192.168.1.10, 1.7, 1. But they all start with 192.168.1. But imagine there is another network starting with 10.1.10, right? You can't connect with a switch. At that point, you need a router. But if you have a layer 3 switch, you don't need a router. You bow. Yeah. So that's basically it. I'll share the lesson I learned in the next video. This is getting long. So yeah, food for thought. Do phones have switches and routers? Think about it.